I'll be driving through these points, like introduce then what is exactly is this ADAS, and what's a normal like normal general block diagram, and then what ADAS is contributing towards this autonomous driving, and some terms and definitions. So start with this ADAS, right? So ADAS is basically advanced driver assistance system. Basically, it is a system that is assisting the driver passively and also actively. By passively assistance, we means it will give alarm sounds or visual notifications, sometimes vibrations, lights, this kind of things. Active assistance in ADAS is how the vehicle will take the control. Okay, it can apply the brakes, do the throttle, control the steering, and make the driver safe. Okay, so this comes when the driver is not controlling the vehicle. He can means it has he has already lifted out the hands and left it's not controlling the throttle, braking, anything. At that point of time, this active assistance comes in and gives some gives some safety kind of thing to the driver. This whole technology is being achieved using, going to the next slide. Let's brief into a complete ADAS system. How this ADAS works in a automotive is, it is a group of ECUs, different ECUs that communicates with each other and give this aid to the driver, as an assistant to the driver. So here, first thing is that there are camera ECUs, radar ECUs, leader, even ultrasound ECUs. All these data comes into for processing. We call that a sensor ECU, where all this data gets merged and the effective data is coming out of these sensors, and based on that, it's get merged with this GPS and vehicle to X, like vehicle to X, vehicle to vehicle, or vehicle to any other things. That data, also the maps data, they combine all this data, and out of that they takes a decision on which the vehicle is being controlled, or a notification is sent to the driver in case of passive. So now let's say this ADAS has to process a lot of data. Camera, there will be not one camera, there will be many cameras, and it need to send a lot of data, and that data also need to process. Radar also such kind of use data, they will send leader continuous, it will be seeing this data. So to achieve this ADAS, a high speed data acquisition and processing in terms of computing power is required. So it cannot be achieved using only one ECU. Okay, so to give some idea about the protocol limits, right? When we use a lean local area interconnect, we can achieve only 20 kilobits of data. It can achieve 1 megabits of data. Even CLAN FD, which is flexible data rate, can achieve up to 5 megabits of data. Okay, but these things are not sufficient to achieve ADAS, because let's say camera is continuously recording the video, so it generates megabits of data per seconds, even more than that. So these basic protocols cannot be used. We need to achieve a higher bit rate, like SPI, which is serial communication, and also Ethernet, like which is 10 megabits, 100 megabits, even 1000 megabits. We call that 1000 base T. 100 is 100 base T X. Okay, so when all these data are collected, and after that we need, means let's say the fusion is also complete, then we need a system which can do a decision out of that data. Okay, that I will show in the next slide. Basically, this is a block diagram here. Camera data going to ISP, image processor, pipelines, radar going to radar processor, leader data, leader GPS, vehicle to X. All these are going into sensor fusion here. After that, this is passed on to another system where the decision has been taking place. This is also can be another issue. It's not the sensor issue, because that kind of computing power is not present in the sensor fusion. And after that, the outputs are passed on to the display or instrument cluster, sounds, views, anything. It is stored there. And if in case of active system, right, that actions takes place, braking, throttle, steering, or any alert system. Let's go and see in a ECU level how this is visible. This is a diagram which is at a block level. On a ECU level, going deep into the actual ADAS systems, you can see all these radars are connected to a ECU here in the first diagram, and it is connected over a fee, which can be a physical layer of communication. Mostly it's Ethernet. Similarly, other ECUs are connected uh, for camera. Then one is for leader. Another is the output. We can skip this part. But all these data are connected to this bus system. Okay, and this is the output that is coming. This is in case of passive safety. Now let's see how.
मी आज गेली होती. माझं ते DSC प्रॅक्टिकलचं आहे ना, ते कोड एकच आहे आमचा आयटीचा आणि तुमचा. तर शीतल मॅमने टाकले, कारण शीतल मॅम म्हटले की एकच चालेल. आणि मग आता आज मी ते होत नव्हतं.
Sorry, there is a question here.
आता ते चेक करायचं. ऑनलाईन ते क्वेश्चनच येत नाहीये ना तुमचे.
Yeah, sorry for that. Okay. Now talking about this role of ADAS in the autonomous driving, right? This fusion data, radar, camera, there is something called a ego motion, okay, which is actually plotting the vehicle, how it is moving through the camera, like how we see in the games, right? So based on that, the motions of the vehicle can be derived, and how many objects or obstacles has been detected. All these kind of data are passed on to the autonomous driving system. Okay, in autonomous driving system, normally what happens in the industry, uh, what I have seen till now, I'm saying there is a to B point trip planning, basically selecting the points in the Google Maps and start the car. Then the car main role is to travel from point A to point B. Okay, and it takes on this fusion data along with the maps and elevations, buildings, all these data sets. Okay, which we can see in the last year, right? GPS and vehicle to X, this kind of data all comes in, and this trip planning happens. And sometimes autonomous driving also work when we leave the system. We do not use the car, we lift our hands. In this case, what will happen, the autonomous driving should have a system which can do trajectory planning, okay, to drive the vehicle by itself to a safe point. So basically I have seen a diagram here. So it creates this trajectory paths. Okay, we will go in this way out of the motions data and this camera data along with these maps and elevations. So out of these trajectory paths, one path is chosen, and based on that, the action is performed and car is moved from the driving point to the safe location. And in complex scenarios, the car can also create multiple or maybe 10-20 sets of trajectory paths, and out of that it tries to find out which one is the best. Then it will try to drive the car in that one. So that there can here we can see, okay, there are at least 20s or more than 20s paths here. So out of the best path, the car will be chosen, um, and the vehicle will be driven. Actually, I'm working in this part in my industry. Okay, okay. I will go to the next one. Yeah, on this uh, ADAS, these are the terms, right? Which we have already seen, right? Leader in slide detection and ranging. I know some long range radar are there. It can, see up to uh, some 30-50 meters. Short range radars are very near to the car, which is mainly used for, for parking, but not for ADAS. I mean, it's no active setting. It's used for passive setting. While we park the car, cameras are used. Different type of cameras are used. Okay, sometimes monocam, tricam, 3, 4 cameras are pointing for one directions, and for parking systems, there will be cameras at all sides of the car. At least 6 to 10 cameras are connected. That will show how when we park the car for parking, right, reverse gear, when this all these cameras get active, and that image comes, and it's bended in a way using uh, using using some algorithms, so that it shows the car from a bird eye view, from the top view. Then is there is fusion is combinations of all these data and creating a meaningful data out of that. These are the terms that are used in ADAS in active safety, like adaptive cruise control, AEB, lane keep assist, lane departure warning, forward collision warning, traffic sign recognition. These are basically only used for driver, notifying the driver, okay, we are going away from lane keep or departure, we are moving out from the lane. Adaptive cruise control, it's normal cruise control only, just when it's adaptive to the front cars. Suppose there are multiple cars coming in the front, like at that time this adaptive cruise control doesn't work. Okay, and the last is here I see traffic sign recognitions. In this part, uh, different kind of traffic signs are recognized, and based on that the car also can take a decision. Suppose at some places we also see there is a speed limit in the road, right? 30 kilometers per hour. So whenever this ADAS sees that sign, it will drive down the speed to 30 until it sees the next sign where we can drive at 50. So this is another kind of driver assistance only. Yeah. So I think this is my short webinar. So if you have any questions on ADAS or autonomous driving, I'll be happy to take that.
Anyone is having any question, you may ask now.
Hello.
Hi.
Sir, I had a query about it.
Yes, please.
Sir, there are multiple issues in the ADAS system. And, I was asking how many ECUs we need, minimum ECUs we need for installing an ADAS system, or it's I mean, increasing in the order.
Yeah. That see, technology is changing every day here. The number of issues also gets changed. When we try for another, when we start designing another car, okay, we want more features. The number of issues also increase. What to cope up this problem, right? So there is something in uh, automotive world has introduced. We call that domain based architecture. Okay, now the issues earlier, the issues are distributed. It's gets connected over some Ethernet or Ethernet CAN or whatever, but it's quite distributed. We cannot know which zone is doing what. But now we are adapting to a different kind of computing in the automotive world now. We call that domain based architecture. So what will happen? Different zones are being identified in the car. Let's say front, left, right, rear. Okay, and there is a central HPC computing. Okay, so what happens? These all these sensors are part of the zonal areas. Okay, let's say there are 5 ECUs in the front that will connect to a zonal area ECU that will again send the data to a high performance computing unit. Okay, so from all sides,
Right.
this data are coming in to the central central HPC. We call that high performance computing unit. At there, these decisions are taken. And this HPC is not the normal ECU that we see. Normal ECUs are microcontrollers. Okay, it can do only a specific task that will only do collect some data and send it. But these HPCs are actually microprocessors. Okay, like
Hmm.
what we see in our phones, computers, laptops. That HPC is that one only. Because when we have huge set of data, we need to also process it, and ECUs do not have that capability of taking that processing and taking a decision out of it. Okay, you can go and search for automotive microprocessors, not microcontrollers. Okay, um, like I'll give you some examples. NVIDIA is developing its own HPC. OEMs are using that. Qualcomm is also developing such microprocessors. Uh, we are also using that. Okay, and also companies are developing their own microprocessors too. Okay, to
Right.
achieve this kind of high computing.
So sometimes what happens? Can we our mobile phone has a powerful processor? Okay, and
Yes. See, I will give you an example here, right? Qualcomm,
yes,
Snapdragon, right? We call that. This is being used in automotive. This is the same as like your mobile phone. The processor is same. It has the same cores. We what we call cry cores, right? There are golden cry cores, silver cry cores. Same thing is being used, but in a different way, intended for automotive only. Okay, right. Anything else? Means any other question you have?
Ledman, if you're having any question, you may ask now. Else we'll wrap up the session.
No, sir. Thank you.
Hello.
No, I said no question from me. Thank you.
Kashish, you can continue.
Okay, thank you. S- Thanks, Rabi, first of all, for hosting the webinar. Your expertise and insights were invaluable for our learners. And thanks, learners, for attending the webinar. I hope this webinar helped you out to upskill your learning and skills. I would like to take the opportunity to introduce our company, ISIE India products and services that we offer in EV technology with a small video. Have a look, please.
Hello, engineers. Do you also want to expand your knowledge of electric vehicles and want to secure a good job in the automotive industry? Let me help you to get there with our online and offline products. ISI India has been offering specific domain courses as per the industry demands with perks like pay after placement, no cost EMI, placement assurance, global wide certification by Automotive Skill Development Council ASDC and National Skill Development Corporation NSDC Government of India. We have range of courses in electric vehicle, computer-aided design and engineering, including postgraduate certification and executive PG program in EV, professional master certification program, specialization programs, fundamental programs, and internship in EV, CAD, and CAE. Our postgraduate certification program in EV is specially designed for the students with 120 plus online learning hours, 100 plus hours of industrial projects and internship to give exposure of various computational tools for hybrid electric vehicle applications. It is a 12 months assured placement course with pay after placement, thus encouraging the learning without financial constraints. The course is globally valid, certified from NSDC Government of India. Our executive postgraduate program in EV is specially designed for the working professional who want to upskill themselves or looking for a career change in the EV industry. With 120 plus online learning hours, 20 plus hours of industrial projects. It is a 9-month assured placement course with globally valid certification from NSDC and ASDC Government of India. Our professional master certification program in EV, CAD and CAE is specially designed for the undergraduate students to pave their career path by providing industry relevant skills with 100 plus online learning hours, 5 plus hours of industrial projects. It is a 6-month placement assistance course with globally valid certification from NSDC Government of India. Along with the courses for skilling, reskilling and upskilling, at engineering institutes across India, we are setting up a state-of-art facility, Center of Excellence for e-mobility research and skill-based education, which is equipped with research and project-based learning-oriented experimental setups. This Center of Excellence is not only limited to educate the students, but also it will be utilized for research, innovation and product design and development. It is a combination of 6 labs including EV powertrain training and research lab, battery BMS training and research lab, EV charging and battery swapping lab, software modeling and simulation lab, innovation lab and renewable energy lab. Each lab is consists of number of customized workbenches and machineries. Few of them includes EV drivetrain experimental setup and motor testing workbench, hybrid drivetrain experimental setup with data logger, EV machine cutout section workbench, 2-wheeler, 3-wheeler, 4-wheeler training workbench, battery load capacity testing, battery BMS with CAN protocol workbench, V2G setup, on or off grid work charging station, battery swapping, autonomous vehicle training workbench, solar power generator and software solutions and many more. No matter from which branch you study, we commit to skill and assure you a success in your career. We have spread the joy on thousands of faces, becoming their partner along with the journey towards success. Join us and take advantage to unlock endless career opportunities.
Thanks, learners, for watching the video patiently. As mentioned, we have a proven track record and believe that our product and services will provide great value for you all. So don't miss out on this exclusive opportunity to discover the endless possibilities of EV. So any of you want to enroll in the course, kindly send us inquiry through a QR code displayed on your screen and take your first step towards a more sustainable and exciting future. Thank you everyone for joining.
Learners, if you're interested in joining any of the program regarding the electric vehicle, you can scan our QR code. A counselor will reach to you within 24 hours.